Hey guys, Oric here, working on the Chapter 1 practice test. Chapter 1 is called Counting Methods, and it's really the beginning of probability in our statistics and probability class. This chapter is going to cover sample spaces, fundamental counting principle, which is the multiplication rule, permutations, combinations, and that's really about it. What we're really doing is setting the stage for working on probability. So we're finding out how many total outcomes certain events have, and then when we figure out, then that will help us figure out what the probability of what different events can have. So here is the practice test. Question number 1 is, a pair of dice is rolled. How many different ways can you get a sum of 8? Now, I'm not going to fill out this whole grid, but when we've done this in class, you can fill out, if you think of this as being the options for dice number 1, you have 6 options. It can be a 1, 2, 3, 4, 5, or 6. And you have 6 options for dice number 2. And you fill out this grid, whether sometimes it's a sum, sometimes we've done product, or just what numbers you can possibly get. There's 36 different possibilities. So for instance, 1 and 1 can be 2, 1 and 2 is 3, 4, 5, and 6. So that would be the sum of dice number 1 having 1, dice number 2 having a number 1, and it would add up to 2. So our total number of outcomes that we can get range from 2 to 12, and there's 36 different possible dice rolls, 6 times 6. How many ways can we get a sum of 8? I'm just going to write it out like this. If we get a 1, there's nothing we can roll with a 1 to give us a sum of 8. So if we roll a 2, we can get a 6. If we roll a 3, we can get a 5. And this would be on our sheet here. 2 and 6 would be 8. 3 and 5 would be 8. 4 and 4 would be 8. 3 and 5 would be 8. And 6 and 2 would be 8. But we'd have 4 and 4, 5 and 3, and 6 and 2. Oop, that's kind of hard to read. 6 and 2. And so there's 1, 2, 3, 4, 5 ways we can get a sum of 8. So when we do get into probability, the probability of rolling an 8 with 2 dice, if you were to go to Vegas and you're playing craps, you have a 5 out of 36 probability of getting an 8. But there's 5 total ways you can get a sum of 8. Okay, I'll try to go a little quicker on the rest of these problems here. Question number 2, when you see a larger number and you're selecting a smaller number from it, it's either going to be a combination or a permutation. If the order matters, it's a combination, or it's a permutation if the order matters. Permutation, P-E, the second letter is E. Yes, second letter is E. Combination, it's O, no. One way to remember permutation and combination. So we have different finishes, first, second, and third place, 25, permutation, 3. And going forward, I'll put the answer in, but just to make sure you know how to do this on the calculator, I'll put the calculator up here. And you put in the larger number first, 25, then it's math on the left-hand side there, arrow over to probability, arrow left or right, you can scroll your arrow either way, probability, and then NPR is permutation. 25P and the number 3. So 13,800 ways we can finish this race with 3 different finishes out of 25 people. All right. Same thing with this question, number 3. We have 10 people, different leadership positions. So we have like a president, vice president, treasurer, 5 different leadership positions. So it's going to be 10P5. Same way on the calculator, and that comes to 30,240. And on your test, make sure you write this down like that. So I know what you did. So if you don't get the right answer, we can figure out what you did wrong. Question number 4, 3 people to speak out of 8 people. Now this time we're taking 3 people and the order doesn't matter. They're just going to speak, and it's not like she's picking to have one person speak first, one person to speak second. So she just wants 3 people, 8C3. On your calculator, same place, 8, click on math, go over probability, and CR this time, and the number 3. And that equals 56. All right, question number 5. Sample space. I'll have a different answer key. For the sum of 2-sided dice, 2 4-sided dice. So once again, we could do our grid here of 4. All the possible outcomes. There's going to be 16 total rolls. And the sample space, you write like this, S, and then brackets. And this is going to be hard with my mouse. And if we get a 1 and a 1, we'll get 2. And if we roll a 4 and a 4, we'll get 8. And we can roll every number between 2 and 8. There's going to be some repeats, of course. 6, 7, 8. My old question was, what's the sample space of a phone number? And that kind of messed people up, so I switched that out. All right, question number 6. How many outcomes are there when you roll a 6-sided dice and flip a coin? Well, this is the multiplication roll. We have 6 options for rolling a dice. So there's 6 options, and there's 2 options when you flip a coin, heads or tails. 6 times 2, 12. We could do a tree diagram, and we go heads, tails. Would be one way to do this. Or I could do 1, 2, 3, 4, 5, 6, and then put a HT after each one. And on this one, I would have six outcomes. And if I roll a head, I have 6 outcomes. 1, 2, 3, 4, 5, 6. And tails, 1, 2, 3, 4, 5, 6. And there ends up being head 1, head 2, head 3, head 4, head 5, head 6, tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. So you can see these tree diagrams can get big in a hurry. So bottom line is, it's just multiplication rule, 6 times 2. Question number 7. We did one like this in class. We have 4 students. It's good to read these questions kind of slowly the first time. 4 students want to be captain of the soccer team. So we have the soccer team and 4. We have 10 on the football team, 7 on the tennis team, and 3 on the cross-country team. I thought I cut that off. I think on the actual test I don't have cross-country team on there. So if we want to have 1 captain for each team, basically this is just the multiplication rule. We have 4 for the soccer team, 10 on the football team, 7 on the tennis team, times 3 on the cross-country team. And that equals 840. The other way to think about this is it's 4 choose 1 times 10C1 times 7C1. But that's the same thing as 4 times 10 times 7 times 3 times 3C1. It might help to think of it this way in terms of part B here. How many ways can 2 captains instead of 1 captain? So now this time we do have to use combinations. Doesn't matter which order we pick the 2 captains in, so we're going to use combinations. 4C2 times 10C2. A lot of times I like to use parentheses just to keep them a little bit separated. Times 7C2 C times 3C2. So a little bit of calculator work. I like to do each one separately. This is the number 6. This is the number 45. 10C2 is 45. 7C2 is 21. And 3C2 is 3. 3C2 is the same thing as 3C1, actually, if you think of how many ways you can pick 2 people out of 3. And then you multiply these together, because we're going to have 2 captains from each sport. So 2 captains and 2 captains and 2 captains and 2 captains. I'm saying and, enunciating and, because when you use the word and, it's multiply. So 6 times 45 times 21 times 3 is 17,010. Possible combinations. Question 8 messes people up. You have 4 multiple choice questions. So if you think of it, sometimes a picture kind of helps on this. You have question number 1, question number 2, question number 3, question number 4. And it's just going to be the multiplication rule and with repeats. Because you can pick the letter A for each option. 5 possible answer choices. So in other words, we can choose A, B, C, D, or E. Sorry, once again, sometimes this looks a little sloppy with my mouse. So you have 5 choices. So I have 5 choices for question number 1, and I have 5 choices for question number 2, 5 choices for question number 3, 5 questions for question number 4. That's 5 times 5 times 5 times 5, which equals 5 to the 4th power. And I don't have that on my, I thought I did this question, but I guess I didn't. 5 to the 4th power. 625. I probably should know that. Okay, Darnell decides to roll 2 16-sided polyhedrons. I guess they're funky dice. I put this on here just to make you think of 2 separate dice. One, just pretend one's blue, one's green. So you can have a blue number 1 and a green number 1. How many total outcomes are there? There's 16 for the first shape, dice, and 16 for the second. So it's just 16 times 16 is the total possible outcomes. And that's 256. 16 squared. How many ways can you roll a 13? Well, you could do a big long grid, but if you think about it, if you roll a 1, you have 16 sides. If you roll a 1, you can roll a 15. And if you roll a 2, or not a 15, sorry, roll a sum of 13. So we can roll a 1 and a 12. You can roll a 2 and an 11, 3 and a 10, 4 and a 9, 5 and a 8, 6 and a 7, 7 and a 6, all the way up to, once we get up to 10 here, it'll be at 3, 11, at 2, 12, and there'll be 1. 12 and 1 will add up to 13. So if you think about it, we can roll, if we roll a 13 on one of the dice, 13, 14, 15, or 16, we can't get a sum of 16. So we have 12 different ways, 1 through 12, 12 through 1 on the second dice will add up to 13. So there's 12 ways we can roll a sum of 13. That one's almost more of a logic than really thinking about how many total outcomes there are. Question number 10. This is one that was off our purple worksheet on Friday. Well, it's similar to it. There's a little bit different number. So the easier question is, how many ways can you select a committee of 4? Once again, order doesn't matter, so we're going to use C, combination. We have 20 total people. Doesn't matter if they're all women, all men, or a combination of both. 20, and we're going to choose combination 4. $10,626. And if you skipped ahead in this video, you can go back and see how to put that in the calculator. Now, if there has to be exactly 2 men and 2 women, well, we have 11 women, and we have to take 2 of them, and it's multiply because we're going to have 2 women and 2 men, and there are 9 men, and we're going to select 2 of them. How many ways of 2 can we get for the men? And order doesn't matter. So 11C2, I'm just sorry, I'm looking at my answer key, and my answer key had different numbers on here as far as how many men and women there were. So let's do this. 11C2, 55, 9C2, 9 math probability, C2, 36. Except I like to do them separately and then multiply it. 36 times, so if you just hit the times, it'll put my last answer I had, times 55. 1980. 1,980. Now this is going to take a second, so I'm sorry, it's going to extend the video a little bit. How many ways can the department of 4 people? It must have at least 2 men. So what we want to think about is if we have 2 men, or we can have 3 men. So now we have or, and now we're going to add that. And we just did in part B if there's 2 men. Or we can have 3 men. I think this is ends up being the hardest problem. 3 men, or we can have 4 men. All 4 can be men. There has to be at least 2 men. I think on the last one it was all women. So if we have 2 men, we have 1,980 possible ways of getting 2 men. And that's 2 men and 2 women. Because we still want a committee of 4 people. So I just took the answer from part B here, right here. Now if we have 3 men, so we're going to add that to 3 with 3 men. So if we have 3 men, we have 11 women and 9 men. So we're going to have 11 women, and we have to choose 1 woman to get a committee of 4. And we have 9 men, and we're going to pick 1 of them. 11C1 is we're going to use 3 men, sorry, 9C3. That's what the problem with doing it without doing it ahead of time. 11C1 is 11 times 9C3. 9 math prob C3. And if you find the mistake on here, point it out to me and I'll give you some bonus points. Hopefully I did this right. 11 times 84. 924. And we're going to add, so we can have 2 men or 3 men or 4 men. So we're going to add combinations of 4 men. So this is going to be 11 women, and we're going to choose 0. And you really don't have to do this. If you do that on the calculator, that comes out to be 1. There's one way to choose no people. You choose no people. and there were 9 men to choose from, and we're going to choose all 4 of them to be men for the committee. 9C4. 9 math prob C4. 126. And so we have 1,980 plus 924 plus 126. That's our total answer of how many ways we can do a committee of 4 with at least 2 men on it. 1980, 924 plus 126. 30-30. Hey. I'm advertising for ESPN, 30-30. Those are good shows if you ever want to watch them. There's one on Randy Moss, that's pretty good. There's a few good ones though. I changed the tree diagram in the test. The test is more like that one homework problem where you can make a ham sandwich or a turkey sandwich, 2 different kinds of bread, so you can have a ham on turkey, ham on roast beef, and then 2 different kinds of drinks, and draw a tree diagram. The idea is the same. This 1, 2, 3 thing got to be kind of, I didn't like this problem that much. But here's how you would do this. There's 3 balls that have a 1, 2, or a 3 on it. You draw without replacing the balls. So you got 1, 2, 3 different ways that you could pick a ball out of the hat. And then you don't put the ball back in. So if you drew a 1, there's not a 1 left to choose from. So you can get a 2 or a 3 on the second time you pick. And if you drew a 2, you could get a 1 or a 3. And if you drew a 3, you could get a 1 or a 2. Now if it said with replacement, like in other words you drew the 1 out and you threw the 1 back in there, then after the 1 there would be a 1, 2, and a 3. So there's your tree diagram. List the sample space. You can get a 1 and then a 2. You can get a 1 and then a 3. You get a 2 and then a 1, 2 and then a 3. A 3 and then a 1, a 3 and then a 2. So once again, sample space is all of the possible outcomes that you can get. And that is the end of the practice test. See you later.